Imagine you're holding a simple plastic cup. It weighs less than a handful of coins, costs only a few cents, and most people throw it away without a second thought. But here's what nobody tells you. Before that cup ever reached your hand, it traveled thousands of kilometers, survived blistering heat hotter than molten lava, and passed a machine so fast they can create more than 1,000 perfect cups every single minute. Today, we're stepping inside that hidden world, where tiny plastic pellets transform into one of the most common products on Earth. Think about this. Every single day, billions of people drink water, coffee, juice, or soft drinks from plastic cups. Global factories produce hundreds of billions of these cups every year, enough to circle the Earth many times if stacked rim to rim. You hear the constant hum of electric motors, the hiss of compressed air, and the rhythmic clatter of robotic arms working without rest. What happens inside these factories surprised even experienced engineers. Most people never think about this, but making a disposable cup demands remarkable precision. The wall of a typical drinking cup measures only about 0.3 to 0.6 millimeters thick, yet must stay strong enough to hold hot coffee or icy drinks without collapsing. Every fraction of a gram matters because factories produce millions of cups every day. Saving just 1 gram of plastic per cup can eliminate thousands of tons of raw material every year. And this is where the journey becomes truly extraordinary. Long before machines shaped these cups, their story begins deep underground, where ancient plants and microscopic sea creatures transformed into oil over millions of years. That hidden treasure will soon become crystal clear pellets, then molten plastic, and finally the cup sitting on your table. But first, we have to travel back to where it all begins. The journey starts beneath the deserts of Saudi Arabia, the offshore platforms of the United States, the oil fields of Canada, and the massive petroleum reserves of the Middle East. Crude oil and natural gas provide the building blocks for most disposable plastic cups. Some premium food containers also use polypropylene made from natural gas liquids because it stays rigid while remaining lightweight. Every shipment begins a global journey that often stretches more than 10,000 kilometers before reaching the factory. Inside giant petrochemical refineries, engineers separate crude oil into valuable fractions using enormous distillation towers reaching nearly 60 meters high. At temperatures approaching 350 degrees Celsius or 662 degrees Fahrenheit, hydrocarbons separate according to their boiling points. Ethylene and propylene gases become the stars of the process. Through carefully controlled polymerization reactions, millions of tiny molecules lock together like microscopic chains, creating the plastic that will eventually become your cup. Freshly produced plastic leaves a refinery as tiny cylindrical pellets, each only a few millimeters across. These smooth beads look surprisingly harmless, almost like grains of rice, yet each one contains years of scientific research. Food-grade polypropylene and polystyrene usually reach purities greater than 99.5% before packaging. Automated systems load thousands of kilograms into giant silos, railway cars, trucks, and cargo ships bound for manufacturing plants around the world. But here's something many people never realize. Those tiny pellets rarely travel alone. Manufacturers carefully blend color concentrates, ultraviolet stabilizers, food-safe processing aids, and recycle material when regulations allow. Computer-controlled mixers measure every ingredient to within fractions of percent because even a slight mistake can weaken thousands of cups. Precision starts long before the first machine ever switches on. Transporting these materials demands astonishing logistics. A single modern factory can consume more than 100 tons of plastic pellets every day. Giant tanker trucks arrive around the clock, using powerful vacuum systems to blow the pellets into towering storage silos. You hear the deep roar of compressors and the rushing sound of millions of pellets flowing through pipelines like an endless white river. Of course, this incredible convenience comes with difficult questions. Producing virgin plastic consumes significant energy and releases greenhouse gases, while discarded cups often end up in landfills or oceans if waste systems fail. That's why many factories now blend recycled polymers, reduce material thickness, and improve energy efficiency without sacrificing strength. The race to build a better cup has quietly become one of the biggest engineering challenges in modern packaging. Now the raw materials are finally ready. Millions of perfectly engineered pellets wait above production line, suspended inside towering silos like a waterfall frozen in time. In just a few moments, gravity will pull them into machines hot enough to melt solid plastic into flowing liquid. And what happens next is the part almost nobody ever gets to see. The moment production begins, gravity releases millions of plastic pellets into the hopper above the forming machine. They disappear into a rotating steel screw spinning between 80 and 150 revolutions per minute, where powerful electric heaters raise the temperature to approximately 200 to 260 degrees Celsius for polypropylene, or 180 to 240 degrees Celsius for polystyrene. Within just a few minutes, every hard pellet softens into a thick, glossy liquid that flows like glowing honey. The air fills with the gentle hum of motors and the faint smell of warm polymer as the factory comes alive. Next, the molten plastic enters a precision extrusion die that spreads it into a perfectly flat sheet. The die maintains tremendous pressure while producing sheets only fractions of a millimeter thick. As the glowing sheet exits the die, polished chilled rollers rapidly cool it in just seconds. You can actually hear the softness as heat escapes and the flexible sheet becomes smooth, glossy, and ready for forming. The cooled sheet now races toward the thermoforming machine. Powerful infrared heaters warm only the forming zone, making the plastic flexible without melting it completely. Think about this. Every section of sheet remains at exactly the right temperature for only a few seconds before moving to the next stage. Even a tiny temperature change can affect the final shape of thousands of cups. And this is where the transformation happens almost faster than the human eye can follow. A precision mold closes around the heated sheet, while powerful vacuum pumps pull the plastic into every detail of the mold. In less than a second, the softened plastic stretches perfectly into shape. Suddenly, a flat sheet becomes dozens of perfectly formed cups in a single movement. Cold water circulates through hidden channels inside the mold, removing heat within seconds and locking every cup into its exact dimensions. The mold opens, the cups move forward, and the entire cycle repeats over and over again. Thousands of identical cups appear almost like magic, but every movement follows precise engineering. Now another machine takes over with astonishing speed. Steel cutting dies punch each finished cup out of the surrounding plastic sheet with incredible precision. High-speed presses can produce tens of thousands of cups every hour. The sharp metallic rhythm echoes across the factory floor like a perfectly synchronized heartbeat. Most people never see what happens to the leftover plastic framework. Instead of becoming waste, automated grinders shred it into tiny flakes and send it back to production line. In many factories, nearly all clean production scrap is recycled immediately. That saves both raw material and energy while reducing waste. Freshly formed cups continue along conveyor belts where automated stackers count every piece with photoelectric sensors. Robotic arms gently lift and align perfectly nested stacks before sending them to packaging. Workers watch computer screens nearby, ready to respond instantly if anything falls out of alignment. Before the cups leave the production floor, compressed air removes tiny particles while automated packaging machines wrap the stacks and print batch numbers for complete traceability. What started only minutes ago as tiny plastic pellets now fills entire pallets ready for supermarkets, restaurants, hospitals, and cafés around the world. Now the factory enters its most demanding stage. Making millions of cups every day is impressive, but making every single one identical is an entirely different challenge. This is where advanced technology quietly takes control, watching every movement with incredible precision. High-speed AI vision cameras inspect every cup as it races down the conveyor. They search for tiny cracks, warped rims, bubbles, burn marks, contamination, and microscopic defects invisible to human eye. Laser sensors measure every cup with extraordinary accuracy, while powerful computers make accept or reject decisions within milliseconds. The inspection doesn't stop there. Robotic gauges automatically verify the cup's height, diameter, and weight. If the software notices even a small variation, it immediately adjusts temperatures, pressure, or forming speed before thousands of defective cups can be produced. The factory constantly corrects itself without stopping production. Random samples leave production line every few minutes and enter the quality laboratory. Engineers test the cups with boiling water, ice water, compression equipment, and stacking tests to make sure they perform perfectly in real-world conditions. Factories also perform food safety testing to ensure the plastic remains safe for contact with beverages. Scientists carefully analyze samples while manufacturers follow internationally recognized quality standards and strict hygiene procedures. Safety isn't inspected into the cup. It is engineered into every stage of production. Even with all this automation, one crucial job still belongs to experienced people. Skilled inspectors remove samples from the line and examine them by touch, sound, and feel. Years of experience allow them to notice tiny imperfections that even advanced machines may occasionally overlook. Once approved, robotic palletizers stack thousands of packaged cups every hour with remarkable precision. Automated guided vehicles quietly transport finished pallets into enormous warehouses, ready for shipment across the globe. The entire factory operates like a perfectly synchronized orchestra. The final rejection rate in a modern world-class factory remains extremely low, meaning almost every cup meets strict specifications before reaching customers. Yet engineers continue searching for faster machines, smarter artificial intelligence, lighter materials, and more sustainable manufacturing methods. Now, let's step back and look at the incredible scale behind something most of us use without thinking. Every year, manufacturers produce well over 500 billion plastic cups worldwide. If stacked together, they would reach far beyond the moon. Thousands of factories operate around the clock simply to meet global demand. The global plastic cup industry generates tens of billions of dollars every year while supporting millions of jobs across oil production, petrochemical refining, machinery manufacturing, transportation, recycling, and retail. A product that costs only a few cents creates one of the world's largest industrial supply chains. China leads global production, followed by the United States, India, Germany, and Japan. Their advanced factories manufacture enormous quantities of cups every day before shipping them to cafés, hospitals, schools, offices, restaurants, and homes around the world. The story of plastic cups began more than a century ago as manufacturers searched for safer alternatives to shared drinking glasses. Since then, robotics, automation, artificial intelligence, and precision engineering have transformed production into one of the fastest manufacturing processes on Earth. The future may look very different. Engineers continue developing stronger recycled plastics, bio-based materials, cleaner energy systems, and smarter factories that reduce waste while improving quality. Tomorrow's plastic cup may use less material, create fewer emissions, and perform even better than today's designs. Did you know that some of the world's fastest production lines can manufacture more than 1,000 cups every minute? Did you know that saving just 1 gram of plastic per cup can eliminate thousands of tons of raw material every year? And did you know that modern AI systems can detect defects smaller than the width of a human hair while the production line keeps moving at full speed? We started this journey with a simple disposable cup, something so common that it almost disappears into everyday life. Along the way, you've seen underground oil reserves, giant refineries, precision extrusion systems, high-speed thermoforming machines, artificial intelligence, laboratory testing, and global logistics working together with astonishing precision. Every single cup represents an incredible combination of science, engineering, automation, and human expertise. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.